All right, in this video, actually I have a mistake here. We're actually looking at section 10.3, which is ellipses. So we're going to look at different kinds of ellipses. And just to remind you from conics, that when we have an ellipse, that it's where we take a cone and we cut it at an angle, and you kind of get this really funky ellipse shape. It actually is how planets go around. The sun is the planets go around in an ellipse shape. The ellipse has a lot of different properties that we use in a lot of different things. It's used a lot in lighting. Now we're going to do an in-class activity where we're drawing an ellipse. So we're going to kind of go through, okay, how do we draw an ellipse? And these are all the different things we need to draw an ellipse for kind of our hands-on activity. So make sure that you get a chance to do that. If not, talk to me. So our goal is we're going to identify and use the standard form of the equations to draw and graph an ellipse. And we're going to use completing the square, a lot like the circle that we did in the last video. So when we go to an ellipse, the big parts of an ellipse are that we have, they call it a covertex. A lot of times I'll call it a major vertex and a minor vertex. So let's talk about this. Let's talk about what is the difference. When we have a major, in an ellipse, you have two options. You can have your ellipse go like this, where the long side is on the horizontal axis, or you can have an ellipse like this, where the long side is on your vertical axis. So what we do is we call that longer axis, wherever it is. And here's the idea, my longer axis is called the major axis. So here, this would be my major axis, and this one would be my major axis. The shorter axis is called your minor axis. So it's kind of the shorter way. So this would be here our minor axis. Now, in these 4 points that are formed, those are called the vertices. These are called the major vertices. Each one is a vertex, and the plural is vertice. And this would be your minor vertices. All right, and this is the other minor vertice. Okay, they call them covertexes, covertices in the book. And I don't care which one you have. So what we have here is we have minor, major, and then the one thing that they don't have on this picture but occurs is foci. And if you had a chance to do the activity in class where we make the ellipses, you know that the foci is a big part of drawing an ellipse, F-O-C-I. So we're going to be looking at these equations. Usually when we're looking at the A and the B, we call usually the A is the major, probably because it comes first in the axis, and the B is your minor. Although what I usually do is whichever one's bigger is your major, and whichever one's smaller is your minor. And then the HK is still the center, so your center is still at HK. And then from there, we're going to go up. This would be my B. This would be my C. Oh, my drawing is terrible. All right, let me see if I can find a better picture. All right, here we go. This is right out of our book. It does a really nice job of saying, okay, how do we get our foci? How do I get our major and our minor? Some things I want to note. The foci is the distance right here is your C. The distance from the foci to your center point is your C. And you get your C by saying that here they kind of explain it right here. C squared equals A squared minus B squared. All right. And that your A or your B here is the distance from the center point to the outer edge. And that is your A or your B alone, depending on which one we're talking about, the major or the minor. Okay. I think it'll be helpful if I just show you some examples. So we have an example here. It's already in standard form for us. So my thought bubble says, okay, I need to find a center point. My center point is at the HK, so it's the opposite of the 5 and the positive 3. So my center point here would be at positive 5, negative 3. Okay? My vertices. My vertices would be plus and minus from your center point. By here, I would be thinking we're going to go plus or minus 6, which is the square root of 36. And from this one, I'm going plus or minus 4, which is the square root of 16. And I'll show you that in a minute. And then for the foci, C squared equals my A squared, my bigger, minus my smaller denominator. So my c squared would be 36 minus 16, and I get 20. So my c alone is the square root of 20. Okay? And that square root of 20 is about 4.5. All right. So center point here. Center point is at negative 5. Sorry, I'm going to move this. Come on. Negative 5, 1, 2, 3, 4, 5. Or excuse me, positive 5, 1, 2, 3, 4, 5, negative 3. All right, so there's my center point. Make it a little bit bigger. There we go. Nice big center point there. From my center point, I'm going to go in the x direction. I'm going to go plus and minus 6. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5. Oh, I got to go way out there. Oh, I got to move over. See if I can move this. Of course I can't move it. It's locked. I'm going to unlock it. I have to move everything over. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. That's why I lock it, huh? 6. Sorry about that. 1, 2, 3, 4, 5, 6. Why did I know to go 6 in either direction? Well, the square root of this was 6, and that is under the x, where the square root of the 16 is 4, and that was under the y. So in the y direction, I'm going to go 1, 2, 3, 4 above, and 1, 2, 3, 4 below. So that I know right away, I know my vertices, okay? So then, I really from this can just draw my ellipse. You don't need your foci if you're going to just sketch an ellipse, although it's nice to put the foci in there. So the foci is about plus or minus that 4.5 in the major axis direction. So 1, 2, 3, 4 and a half. Here's one of my foci. 1, 2, 3, 4 and a half. Here's my other foci. So that's kind of nice to have your foci in there. So all of that just to draw a lovely ellipse. Let's get into how do we get the equation when we don't have standard form. So here, let's look at this form. We have 4x squared minus 40x plus 9y squared plus 36y equals negative 100. First, group out. Group together your x's and your y's. Then, for each x, you take the leading coefficient and you're going to factor out. So here I'm literally dividing both of these by a 4. Here I would divide them both by a 9. So for each x or squared or y squared, you want both of those to have a leading coefficient of 1. Now, the difference is they don't match. Just leave them. You're going to just leave them there. Before, remember how we divided through by everything? Leave them for now. We're not going to divide through yet by a 4 and a 9. We can just kind of leave it for the time being. But we do have to complete the square. So we are going to look at our coefficient of our x, take half of it, in this case 5, and square it. So I'd add 25 here, and in this case I'd be adding 4. But I don't just add 25 to this side, because this 25 is technically being affected by the 4. So I'm going to add 4 times 25. And I don't just add a 4 here, it's technically being affected by the 9. So I'm going to add 9 times 4. Here's it looking a little bit prettier. Okay? So I have to add all of those as well. All right? And then now when I complete the square, show what it would be squared, remember I'm taking half of my b, so it would be negative 5 here, half of this 4, that's how I got the positive 2. And then I added negative 100, this would be a positive 100, and this would be 36, it's 36. So now, the one thing that's unique about an ellipse is it's always equal to 1. So you have these equations where you always have it equal to 1. So in order to equal 1, what I needed to do last is divide each and every term by 36 so that I could set it equal to 1. And it turned out to be x minus 5 quantity squared over 9 and y plus 2 quantity squared over 4. So what do I know about this one? I know the center of this problem is at 5, negative 2. All right. I know from the center I need to go in the x direction, I need to go plus or minus 3. In the y direction, I need to go plus or minus 2. I got those two values by taking the square root of the 9. Since the 9 was under the x, I knew that was the x direction. Square root of the 4 is 2. I knew that goes in my y direction. And then I also could tell you the focus, all right? And my c squared would equal 9 squared, or it's the a squared, it's already 9, minus the b squared minus the 4. So c squared equals 5. C alone would be square root of 5. So in the bigger direction, in the one that's larger, which would be the x direction, it has the larger denominator, I would, for the focus, I would go in the x direction and go plus or minus square root of 5. Okay? So if we wanted points instead of just saying, I kind of know what direction I would be, what you do here is here when I say for this x direction plus or minus 3, you do that with your x. X plus 3 would be 8, negative 2. X minus 3 would be 2, negative 2. Those are called my major vertices. I'm going to do the same thing for my y direction. Now I'm going from this point, and I'm going to say we have 5, and then negative 2 plus 2 would be 0. And then I have 5, and negative 2 minus 2 would be negative 4. These are our minor vertices. And we have our focus. Our focus we decided was affected by the x because the x value had the greater denominator. The x kind of fraction part had the greater denominator. So I'm going to say this is 5 plus square root of 5, comma, negative 2. The other focus is if I went 5 minus square root of 5, comma, negative 2. So if you notice, I only affected the x. It's only going to affect one or the other. So there is kind of all of the details if we were asked for just the details. So we could take all those details and then graph it. Okay? So let's see. Here's the assignment for today. It's from page 637, 7 through 10, 16 through 30. There's our assignment. So let's try problem 23 together. So my steps were, group your x's together. Group your y's together. Put your constants on the right side. So I brought my 9 over. Now, factor out. In this case, I'm going to factor out a 4 because I want to have a leading coefficient of 1. So I factor out the 4, and I have x squared minus 2x. Here, I don't have anything to factor out because I already have a leading coefficient. Notice how I'm leaving space. You'll see why in a minute. Now, I need to take half of my b and square it and add that to both sides. But if you remember, it's not just a 1, it's 4 times a 1. Here, half would be 9. Half of 6 is 3, and it's kind of like 1 times 9 over here. So now, when I complete the square here, x squared minus 1. It's not x squared. I always do that. Sorry, guys. X minus 1 quantity squared. Here, remember, it's kind of like the 1 still there. Y plus 3 quantity squared. And this here would be equals 4. So now, if you remember, I want it equal to 1. So I need to divide each and every value here by 4. And so what I have in the end is x minus 1 quantity squared over 1 plus y minus or plus 3 quantity squared over 4 equals my 1. What do I know? I know that my center is at 1, negative 3. I know that affecting my x-axis from my x vertices is going to be the minor. All right, and it's going to be 1, square root of 1 is still 1 in either direction. So it's going to be 0, negative 3, and 2, negative 3. I know that my major vertices, and because the denominator here is larger, that's why it's major, is going to be affected by the square root of 4, which is 2. So 1, and it was going to be 2 less than that, so it would be negative 5, and 2 greater than that, negative 1. I know c squared is 4 minus 1, the highest minus the lowest. And I'm going to run out of time here to graph it. Look back. I'm going to pause it and show you the graph here. So you see it's kind of a tiny little graph. It has a center, and then it go up from the center to the left and to the right by 1, and up and below it by 2 to find my 4 vertices. And then I kind of put in my foci. My foci is going to be at that -3, and we're just adding or subtracting the square root of 3, which is 1.7. So